Alright, this one actually tells us to, I have the instructions blocked off up there, but the instructions on your chart say use the chart from before to fill in the radius for each given year. Well, in this case, we don't want the radius, that's a typo. We want the circumference, because that's what's missing. Okay? So, remember from the previous problem, the circumference of a circle equals, this one, A equals 2 pi r, or 2d, pi d. Alright, but since we have the radius, we can use 2 pi r instead, and that's fine. So it's r times 2. So it's the radius times 2 times pi. Okay, so 2.5 times 2 is 5, so that'll be 5 pi. 3.1 times 2 is 6.2, so that'll be 6.2 pi. 3.5 times 2 is 7, so that'll be 7 pi. 3.9 times 2 is, what's that, 4 times 2 is 8, minus 2 is 7.8 pi. And 4.4 pi times 2 is 8.8 times pi. And 4.9, that's essentially 10, minus 2 is 9.8 pi. If you don't believe me, do 4.9 in the calculator. And 5.5 times 2 is 11. So that'll be 11 pi. Okay, so we just basically, real quick, plug these guys in for r. So the idea is the circumference at that point is 2 times pi times 2.5. 2.5 times 2 is 5, so c equals 5 pi, and I left it in terms of pi. Okay, I like pi. Anyways, so that's and then it says letter A, calculate the finite differences for the circumference. Well, you notice the pi in this case really doesn't matter to an lost type because we're not adding pi's at all. Oh yeah, we are. We are adding pi's. So for this one, 6.2 minus 5 is 1.2, so we're adding 1.2 pi's. 7 minus 6.2 is 0.8, so we're adding 0.8 pi's. 7.8 minus 7 is also 0.8, so 0.8 pi's. 8.8 minus 7, 0.8 is 1, so 1 pi. Alright, 8.8, it's 9.8 minus 8.8 is also 1, so 1 pi, or I can just write pi. And 11 minus 9.8 is 1.2, so 1.2 pi. So those are the finite differences. And it says, do you think the circumference can be best represented by a linear model? Not, is it a perfect linear model, can it be represented by one? And I think the answer is yes. You notice how this is 1.2, 0.8, 0.8, 1, 1, 1.2. They're all hovering around about 1. Well, 1 pi, that is. Okay. So I think the answer is yes. Because the differences are similar. Find the average finite difference for the circumference and write a linear model for the situation. Well, the average finite difference, okay, so basically if I want the average change in y, I add up all my differences, so that's 1.2 pi plus 0.8 pi plus 0.8 pi plus 1 pi, which is just pi, plus 1 pi, which is again just pi, plus 1.2 pi, and divide it by, well, there are 1, 2, 3, 4, 5, 6 elements, so 6. I'm going to go ahead and add the top row quick. 1.2 plus 8 is 2, plus 8 is 2.8, 3.8, 4.8, 5, 6. So that's 6 pi divided by 6. Well, 6 divided by 6 is 1, so the average difference is 1. That's your average change in y. Okay? So the slope, in this case, since my average y is at pi, since my average x is 1, your slope is pi. So y equals pi times x plus 5 pi. Because that was this is my starting circumference right there. Okay? And that's a linear model for the situation. Alright, I'm going to pause, and I think there's more on this one. Let me make sure before I stop. Oh, no. No, it's not. There's more. Pause. Alright, here we go. This last two questions in example 2. And I gave you your formula, so we have something to go with. Just estimate the circumference in the year 2010. Well, remember 2010, I just got a haircut and I put hair all over the top of this thing. That's gross. Give me a second. Okay, so here we go. Estimate the circumference in the year 2010. Well, if you recall from the previous one, since like x of 0 was for the year 2000, x of 10 will be for the year 2010. So we can plug in 10 for our equation. So y equals pi times 10 plus 5 pi. Well, 10 times pi is 10 pi. So y equals 15 pi. That is the estimated circumference in year 10. Alright. Then it says estimate the circumference in the year 2015. Is the result similar to the answer in part G of example 1? Alright, so estimate the circumference in the year 2015. Well, remember that's an x of the year 2015 is x15. So we can plug that in real fast. Y equals pi times 15 plus 5 pi. So y equals 15 pi plus 5 pi. Y equals 20 pi. And if my memory serves me right, that is the exact answer we got for part G of example 1. Right. So that means our estimate is probably pretty good. Our estimator is probably pretty good, even though we used averages and things along those lines. Alright, well there we go.